Okay, in this video we will go over another type of derivative. We're going to go over implicit differentiation. And so we've typically seen something like y is equal to x raised to the fourth, and that's pretty easy to get the derivative. It's simply going to be 4x cubed. But with implicit, you're going to have to do something slightly different. So let's say we have x raised to the fourth plus y raised to the fourth is equal to 100. So the first step is to differentiate with respect to x for each term. But for the y term, we also need to multiply by dy dx. And then we need to rearrange the equation in order to solve for dy dx. So here it was nice because when you get the derivative, y becomes dy dx, and you just simply want the 4x cubed. But here you're going to have to do that rearrangement. So the derivative of x raised to the fourth would give us 4x cubed plus, for this term, it's going to be 4y cubed, but don't forget, we need to multiply by dy dx is equal to 0 because the derivative of 100 is 0. So now we rearrange, so this term goes over here, so you get 4y cubed, dy dx is equal to negative 4x cubed, and then you can say that dy dx is equal to, you divide this piece over, and so you get negative 4x cubed divided by 4y cubed, which you can simplify and get negative x cubed divided by y cubed. Now that we did an example, if you want, you can pause the video here and attempt this problem. So the first step, I'm taking the derivative of this side and this side. So we obviously know the derivative of 0 is going to be 0. But now we need to do this part right here. So the derivative of x cubed, the derivative of this piece, and the derivative of this piece. So with x cubed, the derivative is going to give us 3x squared. Here we need to do the product rule, but before we do that, we can put the 7 in the front. So we just have x and y. So with product rule, it's 1d2 plus 2d1. So 1 meaning x, d2, the derivative of this piece, plus 2 times the derivative of the first piece. And so this is what we would get. Plus, now we have this piece. So we want the derivative of this piece, so y squared, we get 2y. But because it's y, we need to do dy dx is equal to 0. Now we can kind of expand, so we would get 7x dy dx plus 7y plus 2y dy dx is equal to 0, and we also have the 3x squared. So now I'm going to rearrange. So all the terms with a dy dx, I'm going to keep it here, and the terms that don't have dy dx, I'm going to move it over here to the right. And so I'm going to move this piece, and I'm going to move this piece right here. And that's why I have negative 3x squared minus 7y. And I factored a dy dx for these two pieces. And now simple, I just divide this piece over. So dy dx is equal to negative 3x squared minus 7y divided by 7x plus 2y. And that's all we need to do for this type of problem.